Welcome to the second video taking you from zero to hero on Alexa with Ruby. In our first module, we set up a simple Alexa skill, we set up a tunneled Sinatra application, and we hooked the two together to say hello world. In this module, we're going to handle variable data from users using slots. So this module will introduce slots and custom slot types. And this module uses Sinatra, Ruby's JSON library, Ruby's HTTP library, and the Numbers API. We're going to build a fact-checking mechanism so users can ask for facts about particular numbers. So here are some things that users will be able to ask Alexa. They'll be able to say, Alexa, ask number facts to tell me a trivia fact about 42. And Alexa, ask number facts to tell me a math fact about 5. Users will be able to choose a number, any number, and a fact type. You see here we'll have trivia and math. Alexa will respond with an interesting fact about that number, specific to that type of fact. So let's get started. First up, we're going to scaffold a new skill. So by the end of this, we'll be able to interact with a simplified version of our final feature. Our start point will simply be that users will be able to ask, Alexa, ask number facts about 42. And Alexa will respond with a trivia fact about the number 42. Later, we'll build on this feature to add trivia responses for all sorts of numbers. So to get cracking, we need to sign into the Alexa developer portal. Again, I've already signed in here. And set up a new skill. We're going to add a new skill, and we're going to call it number facts. Again, we'll be using the custom interaction model, and I'm going to be using English UK because that's where I'm currently based. So you can edit the skill that you set up in module 1 or practice making a new one. For now, I'm going to create a new one with a name of number facts and an invocation name of number facts as well. To remind you, this is the name that customers will use to activate the skill. So for example, Alexa, ask number facts, etc. We're not going to be using the audio player, video, or render template functionality. Now that we've set up our skill, let's hit next and give it a basic intent schema. So to remind us, intents are a JSON object with a single key intents that is an array containing an object for each available intent. We're going to have one intent and it's just going to be called number fact. Let's add a simple utterance to invoke this intent. The intent is called number fact, and what we want to say is ask number facts about 42. So before we go any further, let's check that our utterance correctly invokes our intent. We're going to set up an HTTPS tunneled Sinatra application, just as we did in module 1. Of course, if you have a preferred way to provide an HTTPS endpoint to Alexa, by all means use that. We'll proceed under the assumption that you're using ngrok with a locally running Sinatra application. So let's save up our sample utterances and intent schema and jump across to Sinatra. I'm going to make a simple Sinatra application here, so we will start out by creating a gem file. I'll open up that gem file, and I'm going to add in the Sinatra gem. Again, we're not going to test drive this, so we'll just be using Sinatra for now. Let's install our packages to our project. Create a simple server file. And inside that server file, we're going to require Sinatra. We're going to require JSON because our requests and responses will be sent using JSON. And we're going to set up a simple route. Remember, Amazon will always send this directly to as a post request to the index route. We're going to need to respond with a JSON object. So we'll use the toJSON method available on hashes thanks to Ruby's JSON library. We'll need to give it a version and a simple response. This is kind of our minimal response that we could give. Again, it's just going to have one key in the response. That's an output speech object. with a type of plain text, and that text being the number 42 is pretty cool. So this is what Alexa is going to respond to when we receive any request to our application. If you are confused by anything that's going on here, then do duck back into Module 1's video where we talk in a little bit more detail about this minimal response. So let's start our local server. And we'll use ngrok to do the tunneling. ngrok is available for download online. Again, we demonstrated how to set up ngrok for local tunneling in the previous video, so please do refer to that. For now, I have already downloaded ngrok, and you'll see that it's here available. So I'm going to start ngrok with this simple command, ngrok http, and the port number that my local server is running on, which is 4567, which is Sinatra's default. I'm presented with this screen. I'm going to grab the endpoint as I did before. Remember again, it needs to be the HTTPS endpoint, as Amazon does not allow sending requests to simple HTTP endpoints. And I'm going to set up in my Alexa skill the HTTPS endpoint. We're going to be using HTTPS, not Amazon AWS Lambda. And we're going to be using the European region because that's closest to me. I'll paste in the endpoint that I took from ngrok. No account linking or permissions are required. So that's set up. Let's just do a quick sanity check. We're going to use the development endpoint being a subdomain of a domain that has a wildcard certificate from a certificate authority. In this case, the wildcard certificate is owned by ngrok itself, and our subdomain is this number that we've been randomly assigned here on ngrok. Great, so once we start the local server, start ngrok, and provide our ngrok HTTPS endpoint to our skill, we can use the service simulator to test a basic interaction. Or if you have an Alexa device registered to your account, you can test the connection using any Alexa-enabled hardware. Again, if you are struggling to remember how to set up all this local tunneled environment in more detail, there is more guide in the first module blog post and video. So let's connect them together. Our simple utterance was to ask Alexa about 42. Let's try asking number facts. And as expected, we receive the service response that we gave our Sinatra application. That is, the number 42 is pretty cool. And for a further sanity check, we can just go take a look at the logs of our server, and you'll see that we received a post request which was issued the HTTP status code of 200. That means it was okay. And there are a very small number of bytes, just the little JSON response object that we set it up to respond with. So when we ask Alexa, ask number facts about 42, Alexa responds with,
"The number 42 is pretty cool."
We have a connection. So now let's upgrade our Ruby code to give us an actually interesting fact about the number 42. So we're going to be using the numbers API, it's just at numbersapi.com, to give us an interesting fact about the number 42. You'll see here that all we need to do is supply the numbers API with a number, and it will give us some information about it. So we can try it out here online. If we give it 42, it will generate us a random fact about it. In this case, that 42 is the number of laws of cricket. So in our Ruby code, let's change ourselves to make a call directly to this numbers API to grab an interesting fact and then pop it into the response. Since we're making a call to an external API, we're going to need to require in Ruby's net HTTP library. The first thing we're going to do in our post request, we're going to script this, is we're just going to grab the number facts URI so we have a reference to it. This is at http numbersapi.com. In this case, /42. We'll hard code this for now. Then we're going to make a request to that API. and that should respond to us with a number fact. Now all we're going to do is we're just going to change out the text that Alexa responds to, with rather, to the number fact that we grabbed from the Numbers API. Since we've changed the code in here, we'll need to restart the server. We don't need to restart ngrok. Ngrok will just continue tunneling any requests that are sent to this endpoint directly to our local host at 4567. So we've restarted the server, reloaded our code. Let's try asking our same request about 42. And as you can see, our response has changed. Let's listen to Alexa. Alexa, ask number facts about 42.
42 is the sum of the codes of the letters in the words Big Bang using the encoding A equals 1, B equals 2, C equals 3, etc.
Pretty interesting. So this is a great start. We can get all sorts of random trivia about the number 42. If we ask another question, you'll see that the Numbers API will give us a different fact, this time about the angle in degrees for which a rainbow appears, or the critical angle. However, what about trivia for other numbers? So, in that first part, we weren't able to pass any parameters to our application. As a result, we could only ask number facts to tell us about the number 42. If a user wanted to know about any other number, Alexa would just tell them about the number 42. We'd like our users to receive trivia facts for all sorts of numbers. Users should be able to ask, Alexa, ask number facts about, and then any number. Our users should hear a response concerning that number and that number only. So to do this, we need to provide a parameter to our intent and our utterance. In Alexa's terminology, we provide parameters as slots. Slots need both a name and a type. So let's start from the utterance, which is what we want our users to be able to say. To reference a slot in an utterance, we can use curly brackets around the name that we're going to use for that slot. So in this particular case, we're going to use the name number. Now let's add that slot to our intent schema with the same name we're referencing in our utterance, that's number. We're just going to modify our number fact intent. Let's add another key, which is our slots. This is an array of values. We can have multiple slots if we would like per intent. And in this case, each slot is, of course, a simple JSON object with a name and a type. We know already that our name is number. We've already set this up down here. Our name is going to be number according to our utterances. And we want to be able to give it a type. So we're going to choose the Amazon.number type here, which will convert any spoken numbers into digits. So to recap that, slots is an array of JSON objects, each with a name and a type. The name references the slot in the utterances, and the type limits the possible return values that a slot can have. Now that we've chosen the Amazon number built-in slot type, it will convert spoken numbers into digits. So if we say, Alexa, ask number facts about 15, it'll become Alexa, ask number facts about, and then the number 15 in our application. There are many built-in slot types, and you can also define custom slot types, and we'll do this in the next section. But built-in slot types are really handy for capturing user input for common use cases such as numbers, dates, cities, even movies, and so on. So before we change any Ruby code, let's observe how adding a slot modified the incoming request from Amazon's Service Simulator. Let's save up our new interaction model. And we're going to jump into our Sinatra application, and rather than doing any of this stuff, let's comment that out for now, and just go back to printing to the command line any incoming request. So we're going to grab the body of the request, and since it's the string IO, we're going to read it directly. Okay, let's jump to our service simulator. after restarting our server. Reloading the new code. And in our service simulator, let's see what comes through when we say about 15. Again, we're not going to receive a valid response right now because we've taken that all out, but we should be able to see in our server logs the sort of thing that came through. So again, this isn't particularly pretty for us. We could use some sort of pretty print to see that, but what we're really interested in is this aspect of the JSON here. In the intent that came through, we have the correct name, which is a number fact intent, but now we also have this slots entity here. You'll see that slots came through with the name of number and a value which is being converted into digits. So, at the moment, we're not doing anything other than just logging the value for this slot. We're always returning information about the number 42, or in this case, we're now just not returning anything at all. So in our Sinatra application, let's grab the slot value out of Amazon's request and pass that to the numbers API. We'll bring back in our previous code. We're done with logging for now. Let's grab the number out of the slot. We're going to use Ruby's JSON.pass method, courtesy of our JSON library, and we're going to pass the body of the request that comes in. This is going to convert to a hash, and we're going to need to then go and grab the request object that comes in. On that, we're going to need to grab the intent object, the slots object, the slots with a name of number, and the value. So we're going to go through quite a few steps to grab that down. Again, if you double check that against the response that was sent here, you'll see we grab the request object, the intent object within that, slots object within that, slots with a name of number, and the value key from there. And once we have this number, we're going to pass it directly through to the numbers API. So instead of calling 42, we're just going to interpolate into that the number that we pulled out from the request. And we don't need to change anything else. Alexa should update herself to respond with the number fact. Okay, let's go test this out in the service simulator. Again, we'll just restart our server so that we load up that new code. And let's go and ask Alexa for any arbitrary number from our number fact skill. We'll start by asking about 15. And we'll see now that Alexa will respond with something specific to the number 15. In this case, 15 is the number of letters in the words uncopyrightable. I'm not even going to attempt to try and pronounce the rest of these words, and the longest English words with no repeat letters. Let's ask about a different number for sanity checks. Let's try 30. So we could now say, Alexa, ask number facts about 30. And Alexa would respond,
30 is the number of uprights that formed the Sarsen circle at Stonehenge. Also the supposed number of holes forming the arrays of Y and Z holes at Stonehenge.
All the information that a user could possibly want to know about the number 30. And again, that will change depending on the response from the numbers API. We'll always get a new random response. Great. Let's make one final upgrade, and that's asking for facts of a specific type. So far, a user can ask Alexa for number facts about a number, where number is any number. And users will hear an interesting fact about that given number. However, the numbers API can provide two different kinds of facts, trivia facts and math facts. And we'd like users to be able to ask, Alexa, ask number facts to tell me a fact type, fact about any number. And where fact type would be either a trivia fact or a math fact. So, because we are passing another piece of variable information to our intent, we'll need to define another slot. Let's jump back to our interaction model. So, where the built-in number slot restricted us to numbers only, there are no built-in slots that will restrict us to either the words trivia or math, which are the two fact types we can make. So we're going to have to make our own. At this point, it's worth mentioning that slots do not restrict user input to certain values. Instead, they guide interpretation of the user's words towards those terms. So it's still possible that users will give values outside of those that you define in a custom slot type. You should handle that in your application. So let's update our utterance first of all. What we really want is for number facts to tell me a fact type, fact, about any particular number. Now, since we don't have this fact type element, let's create a custom slot type. We're going to call it fact_type and enter a couple of values for this. So in this case, they need to be separated by a new line, and our two options are trivia and math. Hit add, and we'll have created our custom slot type that we can now use. A little bit more about these values that I provided fact type here. They act as training data for Alexa's voice recognition. So just to remind you, they don't restrict users to just the given words. Users can use different words in addition to these two. For instance, if a user said, Alexa, ask number facts to tell me a bicycle fact about 42, the word bicycle would be sent as part of the request. So now that we've defined our custom slot type, we can go ahead and provide the slot to our intent. Remember that slots is an array, and all new slots are objects with a type of name, a key of name, and in this case, the name that we gave it in the utterance below was fact type, and a type. And now we can use our brand new fact type. Let's hit save in the developer portal, just to make sure that that interaction model has been built correctly. So now that we're passing a fact type through to our Sinatra application, we can grab the fact type similarly to how we did the number. And once we have it, we can pass it directly to the numbers API. Let's jump back into our Sinatra application. I'm going to pull this out to a variable to start with because it's annoying me that it's always there, and we're going to need to reference it multiple times. I'm going to replace that with a simple variable past request. And then any call to that request, we can just use the past request variable. So we know that our number is going to be the value of the number slot. And we know that our fact type is going to be the same thing, but for the fact type slot. So we'll go into the request, we'll go into the intent, go into our slots, grab the fact type value. And instead of just passing ourselves through a number to the numbers API, the numbers API will also allow us to pass through a fact type, which we've pulled out of the request. Nothing else needs to change. We should now be able to respond with a simple number fact. So let's test in the service simulator or on any Alexa-enabled device. If we've hooked everything together, we should be able to hear an interesting piece of knowledge about the mathematics of any given number. So let's ask number facts to tell me a math fact about 17. We'll use the full term because that's what Alexa will hear. You see that Alexa will actually handle this response quite comfortably. Our application will deal with it, but at the moment it's just going to give us a trivia fact rather than a math fact. So we haven't restarted our server. Okay, let's try that again. Let's ask Alexa to tell a math fact about 17. So now any response that comes back from our application will specifically be about mathematics. So Alexa, ask number facts to tell me a math fact about 17.
17 is a repunit prime in hexadecimal. 11.
Great. The things you never knew. We can try that with a few different options as well. Let's ask for a trivia fact about 42.
42 is the number of US gallons in a barrel of oil.
Great. So we've hooked everything together correctly. We can use any Alexa-enabled device to retrieve number facts, both about trivia and mathematics facts of any given number. So that's an introduction to slots and custom slots with Alexa.